Hey everyone, welcome to another demonstration video. In this video, I'm going to be showing you how to measure for squareness using a couple different tools, and I'm going to give you a couple different examples on why checking for squareness is so crucial when it comes to welding and fabrication. So to get us started, I want to point out that I've got one plate of steel on our table. This is to keep everything nice and level because throughout the years of continual use, these work tables have been welded on, grinded on, hammered on, all sorts of things have happened to these tables, so they're not completely flat. And so I went and grabbed a piece of material that we can use for a verifiable flat surface, and that's what I'm going to be conducting all of my work on. And so for the first example with checking for squareness, I'm going to be building a miniature table. A table is probably the easiest example to use when checking for squareness. So on this tabletop, this little miniature tabletop piece of plate, I've drawn a 1-inch border. This is going to help me to align the legs for the table. Now, as easy as I'd like to say that aligning the legs onto the table is going to be, that's not always the case. Honestly, sometimes our equipment doesn't cut quite to a 90-degree angle, and then also sometimes we have material that's a little bit warped to begin with, so it's always good to have additional tools, that way we can ensure proper fit up. In this video, I'm going to be using a combination of tools. I'm going to be using a combination square, a speed square, and I'm also going to be using magnetic welding holders, or what some people would call magnetic triangles. So to get started, I'm going to use the magnets to hold one table leg to that tabletop at a 90-degree angle. Now, magnets aren't perfect. They shift around, they move. So I'm going to use an additional tool to check for squareness once my material has been fitted up. And in this case, I'm just using the magnets to hold the material in place. I'm placing one on the side and one on the back. This is going to keep the leg from moving too much in any direction, front, back, right, left. And like I said, I'm going to use an additional tool here. I'm using a speed square just to double check. And you can see that I still have to make a couple of adjustments. Not big adjustments, but adjustments nonetheless. Once you're done with your adjustments, you can go ahead and lay down the first tack. Make sure to chip your slag if you're using a process that produces slag, and then brush off the weld. Once the tack is cooled off, go ahead and check that part for squareness just to make sure that the heating and cooling effect of the weld didn't pull the leg in one direction. And in this case, it looks like it did, so don't worry, this is normal. Go ahead and either use some pliers to try to pull it back into place or gently tap it with a hammer. Do whatever you need to in order to fix the slight distortion. I'm actually a fan of banging on things with a hammer, so that's kind of my go-to method. So once you've knocked it back into the correct position, you can go ahead and replace your magnetic triangles to hold it in place, and go ahead and continue on with your tack welds. And after each tack weld, you want to make sure to chip the slag, brush the weld off, and then check for squareness each and every time, and give it any sort of adjustments that it might need in between tacks. This may seem like a long and grueling process, and sure, it takes a little extra time, but you want to take that extra time to make sure that it's done right. Because if you don't do things right the first time, you're just going to have to spend more time going back and correcting your mistakes. I've sped up this next segment because, well, I don't really need to go into that much detail. You can watch it if you want to, but the gist of it is I'm just using the magnets to hold the legs up in place, assuming that they're at a correct 90 degree. And I'm not going to be using a speed square or a combo square to actually ensure that the legs are to 90 degrees. Again, I'm just hoping that the magnets are doing their job, and this is just a real quick playthrough, and we're going to check the table once we're done. All right, let's go ahead and flip it over and see what happens. It wobbles a little bit, but I also notice that the plate that it's sitting on kind of wobbles too, so I'm going to try to resituate that. To ensure that the plate doesn't move, I'm going to hold it down and try to move the table. And you can see that it still wobbles. So somewhere in our welding and in our measuring for 90 degrees, we were off a little bit. So let's go ahead and flip it over and let's check our mistakes. I'm just going to work my way around the table and use a combo square to check all the legs to see if any of them are out of square. And these tack welds are actually getting in the way, so I'm going to have to switch over to a combo square. This is going to give me a more accurate reading. So I've already found one that looks a little off. And let me just remove some of this spatter so that way I can sit the square onto it properly. And here it looks like we've got another leg that's off. A little bit more off than the first leg I had found. And I'm just going to go really quick and do some double checking. See if any of my previous measurements were off. And although I'm pretty sure just by using a square that I figured out which legs are out of square, another method that we can use is the corner to corner method, and this requires the use of a tape measure. The basic concept of the corner to corner method is using the tape measure to measure the distance between one corner and its opposite corner. And then you do the same thing with the last two. Now, if that doesn't quite make sense, don't worry, I'm going to walk you through it. So we're going to feed out the tape measure, and then we're going to sit the tab on the outside corner of one of the legs. Make sure to place your finger against the tab so that way the tape measure doesn't retract into itself while we're trying to get a good measurement. And this will also keep it from moving around and give us an inaccurate reading. And what you're going to want to do here is you're going to want to find the distance from the outside corner of one leg to the outside corner of its opposite cornered leg. And in order to get a good reading, you might have to move your tape measure around just to see exactly where on the tape measure that outside edge falls on. And the reading that I'm getting between these two legs is 7.5 inches. Now we're going to take the distances between the other two cornered legs. Essentially, we should be getting the same measurement. If not, then that's going to tell you that one or more of these legs is out of square. So again, I'm going to sit the tab on the outside edge of one cornered leg, and I'm going to keep a finger on it so it doesn't move, and then I'm going to take the distance between that corner and its opposite cornered leg. Now the reading here I'm getting is 7 3/4 of an inch. So that tells me we're off. So now the troubleshooting begins on finding out which legs is out of square. So what I'm doing here is I'm just measuring the distances between each leg and its adjacent leg just to see if any of them are off. Similarly to measuring corner to corner, the distances between each leg and its adjacent leg should be equal. If I start finding differences, that's going to help me narrow down which leg is out of square. And after doing some troubleshooting with measuring tools, I figured out that it's more than likely this leg that's out of square. So it's a good thing that only tack welds are holding these pieces onto the plate. So what I can do at this point is I can go ahead and break these tack welds using a hammer, reposition that leg, ensure that it's at 90 degrees using the plethora of tools at our disposal, and then tacking it on, and again, checking for square, making sure things are good to go. And after that, you can go ahead and weld your pieces together. And with this next example, I'm basically doing the same thing. I'm going to be making a miniature table, and as I tack weld each leg onto the table surface, I'm going to be checking and rechecking for squareness in between every tack weld. I'm going to speed this up just so we can save time. You don't have to watch the entire thing. I just wanted to include this so that way you get the idea that checking for squareness in between tack welds and in between welding is crucial to the design of the final product. So if you want to watch it, again, you're free to do so. If you want to skip over it and just watch what happens at the end, you can do that too. And now that all my legs have been tacked onto the second table, let me go ahead and flip it over and we'll check it for any kind of wobbliness. And you can see me pushing on it. It's not wanting to wobble. It looks pretty sturdy. It's standing in place. So that's a key indicator that all four of my legs are square. But just in case, I'm going to go ahead and measure corner to corner anyways, just as another form of rechecking my measurements. And on this first measurement, I'm getting 6 inches and 1/8. And on this second measurement, I'm getting 6 1/8 as well. So here we go. That's our double check. All four of our legs are indeed square. And this is the difference between completing a project correctly, making sure that everything is square or fitted up to the appropriate angle, and then doing something where you're kind of cutting corners, where you're doing things a little faster than what you should, and just ensuring that things are done correctly. And this is going to be our third and final example for measuring for square when fabricating projects. So here I've got a couple pieces of flat bar. You can use this concept and apply it to stuff like pipe, square tubing, plate, so on and so forth. This is kind of a general example, but you can fit it into a lot of different scenarios. I'm going to try to connect these together at a 90-degree using the magnet, and you can see that it doesn't quite work. So in some instances, you need to get a little creative. You can try using a combo square, or you can try using a speed square. And you can always double up on the ways that you check for squareness. In this case, I'm using a speed square and a combo square. And now that I've made sure that both my pieces are aligned in a 90-degree angle, I'm going to hold that bottom flat bar down and I'm just going to draw a line across that top edge. And then I'm just going to go ahead and draw a line against the other flat bar as well. And I know it kind of moves, so I'm going to resituate them at 90 degrees. Now keep in mind, these pieces are probably only like 12 to 14 inches long. I honestly can't remember. So this is just a small example. Try applying this example to pipeliners. Imagine setting in a 20-foot length of pipe in the ground and welding it incorrectly. I'm going to show you what something like that might look like. So I'm just going to push this lower flat bar a little up on the plate on one side. So if I zoom in at the corner where they meet, you can barely see a difference. You can't really tell that one side is off and not the other. So this is what a lot of people will call the eyeball reference or the eyeball check, where they're putting something together and they stand back and they kind of say, yeah, it looks good to me, sure, let's go with it, without actually checking it. So now what I'm going to do is I'm going to draw another line against that top edge, and we're going to see if there's a difference, and if so, how big of a difference. And of course, I'm going to label this one as the second line. So now as I remove that flat bar, you can see right there at the joint where the two bars meet, there's hardly a difference. It's not noticeable at all. But then as we travel down, say 12, 13 inches, you can start to see the difference. And that's about a 1/8 inch difference right there at the end. And this is just over a foot in length right here. So imagine what the result would be like if you were setting in a 20-foot pipe. You didn't check to ensure the alignment was correct. And so at one end, it looks kind of good. And then at the other end, 20 feet down, you're probably going to be off maybe 5 or 6 inches. Now imagine trying telling your boss that and then having to go in and do some rework. So the point is here, always check for squareness, check for proper fit up, always go that extra distance, spend a little bit more time just to make sure that your parts are put together correctly.